Okay, select all. Okay, software will check if any warning messages are present, means any overlapping. Okay, model has been checked, no warning messages were generated. Okay, just click 3D view. Now I will go in the run analysis. Okay, analyze. You can click here run analysis, or you can click here. Either way it is okay. Okay, now the analysis is complete. If I want to see anything like deformation, shear force, bending moment diagrams, here for bending moment diagrams, here for support reactions. Okay, for example, if I want to see against the dead moment 3 apply. Okay, you can see all the values are appearing, moment values. Okay, in the plan that will be look very good. So our secondary beams are simply supported, so no negative moment is appearing, but the edge beams and the primary beams are the fixed ended beams, so negative moment is appearing. Okay, so you can see of all stories. We have not defined the load combinations, so we can go add default design combination. So that is our steel frame design. Okay, composite beam design, and convert to user editable. Software will generate automatically all the combination. Okay, you can go display frame. Now you can also see against the combinations. Okay, apply. Okay, if you want to show the values, apply. You can also see the values, for example in the elevation 1. Okay, we are unable to see clearly because due to the cladding. I want to disable the cladding here in the journal. Sorry, object assignment or other assignment, you will see null areas. Okay, here all null shell areas apply. Okay, now you will see the good view. Okay, there is a positive moment, negative moment. Okay, with values. Similarly, you can also see the shear values. Okay, if you will click on the right side on any beam or column, you will see the detail values. Okay, here is the shear, moment and deflection. Okay, you will just scroll left or right on the beam. Okay, you will see the values. For example, at this location shear value is this, moment value is this, and deflection values is this. Or you can put any value. For example, I want to see at 2 meter. Okay, software will show me at 2 meter. Okay, similarly for the deform shape, display show deform shape against any values. For example, either earthquake wind loads are applied or not. For example, wind in X direction apply. Okay, you can see. Okay, the values 4.98 millimeter. Okay, similarly, let's see earthquake are applied or not. Again, you can see earthquake are also applied. Okay, so now the analysis is complete. Now I will go in the design. First of all, I will go in the steel frame design. I will check the preferences. Okay, you can also view the preferences. If you want to change, you can change. Okay, but I want to go with these settings. Okay, in the design, steel frame design. Okay, before going in the steel frame design, I want to go in the composite beam design. Composite beam design, these are all the secondary beams. So here in the design, composite beam design, again check the preferences. Okay, all the values. Okay, design, composite beam design. Okay, select design combinations for the composite beams. Okay, so that is are just simply supported beams. So there are two basic combinations, 1.2 dead, 1.4 dead. Okay, for the composite beams. Okay, for strength criteria, for deflection criteria. Okay, now I will go design. Okay, start design / check. Now the software is designing the composite beams. Okay, so here you will see, just right click. Okay, when you will see here is a last analysis section, mean when I have run the analysis section was W250 by 131, but software has designed the new section that will satisfy the moments and shears, that is W310 by 21. Okay, so I will go in the design, composite beam design, and check verify analysis versus design are same. Software is saying 150 sections are different. So I will again go in the analysis. Okay, and now the analysis is complete. I will go in the design, composite beam design, start design / check. Okay, so now right click. Now the new section is last analysis section and design section is same. So let's see, is it same for whole building? Design. Okay, verify analysis but the design section are same. Okay, now all these analysis sections and design section. Now the analysis and design section are same. I want to go back in the frame sections. Here is a composite beam. Here modify. You will see in the composite beam I have defined multiple beams. Software first run analysis from taking the just previewing the trial sizes, maybe this section, and then do the designing. If the previous section is failed, software automatically select the higher section. Okay, so when I have select the higher section, software said that the previous analysis section is different from the new section. Then again run analysis and design. Now the new analysis and design sections are same. Here right click. Okay, you can see here W310 multiplied by 21. Okay, so now I will select all. I am going to fix all these secondary beams. Select all beams, go to design, composite beam design, make auto select section null. Okay, okay. Okay, sorry, design, composite beam design. Okay, so here you can see W310 by 21. Now the auto list have been disabled. Okay, for the secondary beams, not for the main steel frames. Now I will go in the steel frame design. For the steel frame design, I have to select all these beams. Select frame members. I have select all these beams, so I will select manually. For example, see here this beam have bracing at the location 1, at the half, at the 75%, mean 25%, 50%, at the 75%. I have select all the beams. Ready. Okay, here all these beams have bracing at 3 locations. Go to design, steel frame design. Here is a lateral bracing. Okay, I will specify point bracing. Okay, the bracing at the basically bottom location. Relative distance I will choose. Okay, at 0.25 location, bottom at 0.5 location, bottom at 0.75% location, again bottom. Okay, again you can see. Okay, okay, now bracing have been assigned. Now I will go in the design, steel frame design select design combinations. Okay, you can see design combinations have been selected. Now again, steel frame design, I will select for the run analysis and design. I have to run analysis. Analysis is complete. Now design, steel frame design, start design. Okay, so here analysis and design section differ for 235 steel frames. So do you want to reiterate the analysis and design? Yes. Now only 23 sections, frame sections are different. Okay, yes, I want to reiterate. Now only one member is different. Do you want to reiterate? Definitely yes. Now analysis and design has been complete. For example, here is the beam. Right click Here is all the information. Here is the axial plus bending in major, bending in minor. Okay, the interaction equation ratio applied over capacity. Here is the value 0.138. If it is less than 1, then your design is okay. Here is the detailed report. You can print or you can save into Word file. Here is all the information about, for example, which combination. Okay, design section. Okay, there are all the parameters which you need for the which you need to study. Here all the parameters you can study in detail. Okay, so now I will show this design composite. Again run the composite design. Here you can also see the detail of composite beam design. Right click. Here is the information. Here is a strength checks. Here is a constructability and serviceability checks, mean deflection checks. Here is a shear struts you need for the connection to the deck slab. If you want to the percentage composite action develop between the steel beam and the deck slab, then how much you need, how much shear struts you will provide. For the 27%, here is a design 148 capacity of this beam. If you want to build more composite action, for example 55%, then capacity will increase, and here you have to provide more studs. Here is the deflection criteria. Here is the total deflection in millimeter 13.8. Here is due to live load, and here is the allowable 25 millimeter. That is okay, within the limits. Again, you can also see the report here for the composite design beam report. Okay, you can also study this in detail. Now I will show you the last thing, which is the wind loads. So the direction of the wind load. Here I will go in the display, load assign, shell objects. Okay, I want to show you wind. Okay, apply. Okay, wind load is not appearing. Why? Because I have disabled the null area. Apply. Okay, now you can see the direction where I have when I applied at the start, I have put -8 because the local axis is outward. So now it is showing the direction of the wind load in the x direction, and here is the leeward, windward and leeward in the x direction, and here for the wind y, apply. Okay, wind in positive direction, here that is outward. Okay, so that's how our wind load is okay, as we have defined. So if in the analysis and design your members are still failing, then you can increase your auto list. For example, for the auto beam, I have taken this much list of the beams. You can add more beams. Okay, higher section of beam. Similarly, in the column in the composite beam. So that's how you will design the steel building in ETABS. There is one more beautiful function, that is detailing. Here in the detailing, when you run detailing, already okay, yes, there is a okay. So here is the detailing. I want to close my one window. Here is the detailing. Okay. Okay. So in detail, for example, floor, story 5. Okay. Here is the secondary beam details, main beam details. Okay. Now, for example, in the beam details, steel beam. Okay, these are the all from framing plans of each story, and here is a steel material detail, how much steel is required. So here is in total in metric ton 29. Okay, 43. So that's the steel schedule. of mean BOQ, bill of quantity. Similarly in column, framing plans, okay, sections, here is column schedule. So that much steel is required, number of members, length of members, okay, frame views. So that's how you can see in detail the detailing generated by the ETABS. You can also take all these drawings to the AutoCAD. Here right click, export view. Okay, you can export into the AutoCAD file. Or here is the drawing sheets. You can also export drawing sheets into the AutoCAD. Export drawing sheets. Software is asking you want to convert into as a DXF format or as a AutoCAD file. So that's how you will work in ETABS for the steel buildings. Have a nice day.